I'm Gail Claypool. I did topic A for U-Substitution, and we're just going to delve right into this. So our problem is an integral from 0 to 4. We have x cubed, the square root of x squared plus 9 dx. So looking at this, we want to find a u, and the most logical u for this is going to be what's under the square root, so an x squared plus 9. So as you see, I solved out for an x squared over here, but I'll get to that in just one second. But we know that our u is going to be x squared plus 9. We then take the derivative of that to find a du, and we've got 2x dx. So we want to get the dx by itself. So then we just divide it over, and then it becomes a 1 over 2x du equals dx. So the reason why I split this into an x squared is because we notice that we have an x cubed here, and that is like that problem we did in class with the extra x. We know that there is something there, but we don't know what it means yet. Well, we can use it to get a formula to solve for something. So we split off an x from the x squared to get something we can use this formula for. So we plugged that in for it, which was our 6 minus, or which is right what we have right there. Sorry, I cannot quite see that. It's u minus 9. And we then remember we had that 1. This turns into a u to the 1/2 power because it was a square root. Remember we kept that du here. And I put a 1/2 out front because x times 1 over 2 squared like we had up here is just 1 over 2. So that 1 over 2 remains a constant throughout this entire thing, so we just put it right in front of the integral. So as you see, we do our antiderivatives right down here, and we keep that 0 to 4 integral on the side, so we know that that is what we're going to use to base our scale of our equation that we'll use. So I simplified the antiderivatives here, so we have 3u to the, I believe it says 2 over 5, correct me if I'm wrong, and this is a 1 over 5u to the 5/3, also correct me if I'm wrong, but that is what it should be. So then, knowing our u, which is x squared plus 9, we can then plug it in for the u's that are in here, keeping our 0 to 4 integral there. So from here on, it's just cake. We just plug in our b values, which is 4, and our a values, which is 0. Plug in that for the x's in here, and then we get it simplified to just these numbers subtracting, which our final answer should be 1,412 over 5. So the key to solving these is just make sure you keep your formulas just clear on the paper and just take it one step at a time. If you have any values with that come out to 1/2 like this, keep it in front of the integral because it makes it easier to have it notice where it is and be able to solve it. And just make sure you simplify your antiderivatives, and then you should be all set.